Welcome back to your channel Balvigan Bharti. In this chapter, as I said yesterday, before moving to the next set of problem, we'll discuss first about the standard series which can be used directly in any problem that comes. The same thing I will show you by example. I will try to show you so that what I am saying can be understood by the viewers. Okay. So first of the kind that the that series which is a natural series, a natural series. Okay. Can you see me? Yeah. A natural series. A natural series means the number which is to be started from 1, and the consecutive numbers are having the increment of 1. So that means all the numbers, all the integers basically starting from 1 and continued up to some limited term. Let's say I am talking about the nth term. So this series being expanded till nth term. N could be any finite term, anything you can expect, that could be 100, 1000, anything. This is finite, that is not very infinite kind of. Okay, so in this case, what would be the standard formula for that? For this series, we can use the summation formula. I am talking about the summation is n into n plus 1 by 2, and the nth term basically you can say this is the sum of n terms, and this is the nth term is n, that you can understand directly. So how do this come? That is also very easy. If I put the formula for Sn, that means the general formula for getting the summation is, what is that? For any AP series, n by 2 into 2a plus n minus 1 into the common difference d, isn't it? So this is my formula to get any sum of any arithmetic progression. Now you can see this series is arithmetic progression because the term is starting with 1 and the consecutive terms having the difference always 1. If you subtract any term from the further term or the next term, you will get 1. 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3. So that's why any natural number series is an AP, and using this formula you can get the sum, this one, and this can be used directly in case any need. So now 2 into a is the first term is 1 plus n would be 1, n would be n, and d is again 2 minus 1 or 3 minus 2, whatever you say, it is 1. So now if we simplify, you will get 2 plus, you can remove the bracket here, n minus 1, and ultimately 2 minus 1 is 1, and the remaining will be n there, so n plus 1. So this is the direct formula for any natural series. Means natural series is always 1, there is no gap in between. So all the numbers in the natural series, set of natural series number expanded up to n, having the sum of n into n by 2, n plus 1. So this is the formula. Now why I am saying this formula can be used wherever it is needed to be used directly, you can use it. The next, I will come to that by example where you can use the next set of natural number would be the odd number series. Now we will talk about the odd numbers integers. Now we are talking about the odd numbers integers, means starting from 1 if we go. So this is also to be said as positive integers. So this can be also applied for including means negative integers also, but we cannot club negative and positive together. Now whatever we will talk about, either negative or the positive integers. So in that case, the odd numbers integers which are positive are 1, 3, 5, 7, 9 and dot dot dot. Let's say this also being taken as to the nth term. Okay, now in this case, what would be the sum for this series? Okay, the first, there are two things we have mentioned here. One is the sum of the series and the nth term. Now it is very easy here to get the nth term is as n, because the term number and the position is equal there, as because it is natural series. Now here we are skipping some numbers because we are skipping the even numbers, so this should not be or cannot be the same. So in this case, if I want to calculate Tn, so for that we are having some formula a plus n minus 1 into d, as per any AP series formula, the nth term for that AP series. And you can understand this is also an AP series, the odd numbers integers, because 3 minus 1 if you do, you will get 2, 5 minus 3 will do, you will get 2, 7 minus 5 will get 2. So all this having the common difference, so this naturally can be taken as an AP series. So now by that, a is taken as 1 because the first term is 1, plus n minus 1 into d is equal to 2 here. So now if you simplify this by removing the bracket, you will get 2. So that is 2 minus 2n minus 1. So this is the nth term for any odd number positive integer series. Okay, so what would be the Sn then? So Sn also you can put the direct formula, as because it is an AP series, so that will give you n by 2 into 2a plus n minus 1 into d. So here again, if we put the value, we will get 2 into 1 plus n minus 1 into 2. So remove this bracket, remove the bracket, we will get n by 2 into 2 plus 2n minus 2. So that means if I simplify further, we will get n by 2 into 2n. So that means equal to n square. Now this is also a empirical formula for odd number starting from 1 and taking up to the nth term. So the sum will be the number of terms square. Okay, so this is one formula. The next one will be your even number series. Now the next variety is taking even number integers which are also taken to be positive integers I am talking about. Okay, because this will not complicate the thing. You can mix and match also by taking negative and positive. Then in that case it will be a different result. But what I am talking about, without complicating the thing, the odd number series I am talking about, even number series I am talking about, and this can be used for any case where this has to be used directly. So this time I am taking, so what would be the even number series? Definitely one has to skip, because we are taking the first even number is positive, even number is 2, then after is 4, 6, 8 and all that. Let it be also extended up to nth term. Okay, so now in this case you can see the common difference is also 2, as because we are skipping the odd number, so this definitely will come, but starting from 2. So in this case, what would be the nth term? It is, again, if I use the formula a plus n minus 1 into d, a minus n minus 1 into d. So there you can put the first term is 2, n minus 1 into d also is equal to 2. Now if I simplify, you will get how much? 2 plus 2n minus 2. So you will get 2 into n. So that also you can find out by using your common sense. Any term will be multiple of 2, because even number is by definition is the number which can be divided by 2. So definitely you will see that every term is just twice the number position. So that means if I say 2 into 1, so this is one number position, 2 into 2 second number position, but multiplied with 2, 2 into 3 third number position. So this series also can be written as, without harming the integrity of the series, 1 2 3 4 like that. So again this is the, if I take 2 common, this is nothing but the natural series. So in this case, by this symmetry we can say that the sum of the series, and here the number of term will not be changed, because this is, if it is extended up to nth term, after taking 2 common, this also has to be up to the nth term. So what would be my answer? This is 2 into the sum of the natural series. Now we know what is the sum of the natural series is n into n by 2 into n plus 1. Now see, in this case, while I am doing the sum, we are using the sum of the natural series directly. We are not going to prove it or going to calculate it further, because this is standard and there is no harm in using this standard formula. So this is I am talking about. We'll see further few examples also. So this you can see the sum of the number, even number series is given by this, okay, and sum of the odd number series is given by this, and sum of natural series, where for this case we have used the sum of natural number series. Okay, so this is the way of finding this. Now we will see some example where this kind of series or the standard series can be used effectively or directly. Okay. Now let us see one series. You have to find the sum for this series. Let's say I'm taking a series my own. So I have to find the sum of 1 plus 3 plus 7 plus 13 plus 21 plus dot 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 dot, and this also extended up to nth term, let's say. So now if we see this series, this is definitely a series or sequence you can take, where as I said, the sequence is nothing but any series, any number series which follows some pattern, okay, but definitely it's not that always it will follow any AP pattern, AP series pattern, or any other series pattern where symmetry will come. Here you can see the terms are not symmetry. If we see apparently that 1 2 3 is having a difference of 2, 3 to 7 having difference of 4, 7 to 13 it is a difference of 6, and like that the differences are increasing. Okay, so this is very interesting kind of series, but it, and somehow or the other, this having some symmetry. If you see properly, what is the symmetry? If I take the difference between these two terms, I am getting 2. Okay, if I getting the difference between these two terms, I am getting 4. Okay, if I take the difference between these two, I am getting 6. If I getting the difference between these two, I am getting 8. Now you can easily catch the change, and you can understand the difference are following an AP series, because if we further differ the terms, between the difference of the consecutive terms, you will get an AP series, because 4 minus 2 is 2, 6 minus 4 is 2. So you can understand up to that, oh, definitely it is following some pattern, and when you will take the difference of the term, I am getting the difference, and that difference itself is an AP series. But how to solve that thing? Okay, so how to get that thing done? Okay, so now to solve it, there are few more tips to be followed, and in the process you need to have use those direct formulas. Now what I do, I will write the term whatever way it is written similarly. Only thing is that I will go up to the nth term, let it be Tn, I am just marking it. Now I will write the sum again, but this time I will shift the term one step ahead. That means the first term of this I will put below the second term, so that way the second term will come below the third, and likewise all term will progress one term further. Okay, now in this way the term that will come below Tn, it will be Tn minus 1, and Tn will be shifted one step ahead. Now if I subtract it, if I subtract the left hand terms and the right hand terms, what I will get, these two are S, so that means the result I will get 0 if I deduct, and the thing I will get here is 1. Deducting this, I will get 3 minus 1 is equal to 2. Here I will get 4. Here I will get 6. Plus here I will get 8 plus dot 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 dot, and the thing I will get Tn minus Tn minus 1 here, and the ultimate term will be, I will get Tn, because Tn will get negative sign as because it is in the lower part of the subtraction. Okay, so if I bring this on the left hand side Tn, so this Tn is denoting the Tn term of the actual series, because this has been taken as Tn term of the series, and this has came as a result as a negative. Other terms are coming as positive. So what I can see, this is giving some series plus 4 plus 6 plus 8 plus dot dot dot. Now what would be the situation here? Because from this to this having n number of terms, once it is shifted here, so ultimately from there to there, means ultimately from the starting of the first S and end of the second S, once it is shifted one step ahead, the total number term from this to the end, it is n plus 1, means I am talking about the number of terms, not the value of the terms. So up from here to the end of the terms, it is n plus 1 term. Now this, if I take out this side, so this remaining series before this before this minus Tn, it will end up to the nth term. Definitely whatever be the numbers in the series, this will be extended up to nth term. Definitely yes. Now whatever the value of this, that can be taken care. Okay, that has some clue from the series, what is established by deducting the series. From this I can understand or calculate the nth term. But first thing you have to understand how many terms you are having. Once we are subtracting by shifting one term, so we are adding on the totality one term ahead, so that means we are now dealing with n plus 1th term. But out of that, this Tn terms, once it is taken on the left hand side, the remaining will again be the nth term, because we are deducting one term here this side. Also it is significant that whatever value I am getting by summing of all this will be the nth term of the actual series, because we have taken the nth term as Tn. So this is coming as it is here. So whatever the sum will come here of the value of the thing, whatever I am seeing here, it is the Tn term of this series. Okay, so now if you see the series, this one, except this one, if I see all the term having the common difference between the two consecutive terms is 2. So but only one is not following this series, so I can separate one from here, and the remaining I can keep in one bracket. So in this case, the number of term in the bracket will further be reduced by 1. So this will be continued up to n plus n minus 1th term. Okay, because I am reducing one term by taking one physically out and keeping all other terms in the bracket. So inside the bracket there will be n minus 1th term, because all total including 1 is the nth term. So if I deduct 1, so I will get n minus 1th term. Okay, by doing so, and as it is, you can see that this series is again nothing but the series of even numbers. Okay, now without making much complication, if I take 2 out, so this will turn into a series that will be a natural series extended up to n minus 1th term. Okay, fine. So what I have learned a few minutes ago, that any natural series having the sum of the formula for, if it is extended up to n term, is n into n plus 1 by 2, where the number of term is n. But what is the difference here? The number of term is n minus 1. So what I have to do? Instead of n, I have to put the value n minus 1 and I have to see the result accordingly. Okay, by 2. This is the formula. I am putting the formula for natural series, but it is extended up to n minus 1 term, one term lesser than the formula that have we established. So in place of n, I will put n minus 1. So 2 will be cancelled out, 1 plus, but would remain here n into n minus 1. This will be the remain. Now further, if I reduce, if I simplify, it will be n square minus n. So this, if I arrange properly, n square minus n plus 1. So what is this? This is Tn term. Okay. Now up to that, what we have found? We have found the nth term of the series that has to be summed up. Now not yet we have finished. Okay, so here you have seen that we have used the formula for natural series directly without computing the sum. Okay, so only thing is that you have to see or look after how many terms it is having in the set, so that if you missed, then you will make mistake. Not always you have to put n into n plus 1 by 2. You have to see the number of terms accordingly. In place of n, that much term has to be established, or you have to put the value and you will get the result accordingly. Okay, so now this is one. Now further, what have to do? Now in the series, n is n. What is n here? N is the number belong to the natural number, where n is, this is up to nth term, is the first term, second term, third term. Value is different, but this position is signifies this n. So n, if it is said to be third term, so this will extend up to this. So n is always belongs to natural number. Now if it is so, if n is belongs to natural number, now in this equation, if I put the value of n starting from 1 to the nth term, that will be the series itself. Now this series I have taken such a way that nth term can be represented with this expression. Understand? Now in this expression, whatever the value I'll put from 1 to n, if I do the sum of this series, I will get the sum of this series itself, because this signifies the nth term of this series. Now if I put value 1 to n, as it is seems to be having this number 1 to n, will give you the same result. So if I put n is equal to 1, this will give you 1 square. I am not going to calculate it, rather I will keep the things as it is. Okay, minus 1 plus 1. T2 if I keep, it will give you 2 square minus 2 plus 1. T3 if I put, this will be 3 square minus 3 plus 1. Understood? Like that, if I go on putting the value and I will extend up to Tn. So my value will tell you the expression as n square, because all natural numbers are coming consecutively, and we are putting changing the value of n and putting in the expression to get the terms accordingly. Now without calculating the individual terms, if I sum up column wise, then what is this signifies? T1, T2, T3. This is the T1, T2, T3, T4, T5. This. So this signifies the sum S that I have to calculate here. Understand? Now this will separate the thing into 3 different column sum. So what is that? The first column, if I sum separately, it will give you some series which is a square of all the natural numbers. Okay, plus dot 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 plus n square. Now this is nothing but the value of the term of nth term. It is not the term position. It is the value, because the first position value can be written as 1 square minus 1 plus 1. Ultimately you will get 1. You see, if you calculate here, you will get 3. So accordingly, what I am doing, I am just finding some similarity where you can use the direct formula. The second series is the sum of natural numbers. Okay, and the third one, you are getting all 1. So how many 1 you can find? You definitely from 1 to n, if it is n number, so definitely n number of 1 is there, so you will get n. So now you can understand the series is being divided into this much of thing. Now sum of this series, what would be the value for you? Okay, 1 square, 2 square, 3 square, 4 square, what would be the value of it? Now this I have not yet covered in AP. Let me come up later. But here, this one, it is a sum of natural number, and this is extended up to nth term. So this definitely will come n into n plus 1 by 2, and this is n. This is natural number. Now what would be the value of this sum? 1 square plus 2 square plus 3 square plus 4 square, like that. What will be the value of that? This I am not yet taught you. So right now I will just keep it as it is. Okay. So this needs some concept to be understood. Then after I will show you what is the value of this. Okay. Till now, what I am just trying to make you understand that anywhere by this way, wherever it is needed, I can put the sum of the straightforward or the symmetric series sum directly in case it is needed. I need not to derive every time to get the result. Understood? Now to find this kind of series, sum of the series, a different concept is needed. I think I should hold it for some time because this needs some different concept to find, but this is a general concept for this kind of series altogether, but that is also a very not a straightforward concept, but I can assure once I will show the concept we can apply it to any kind of this kind of series of higher orders also. So I need to have some time to discuss about this. I am holding because this will off-route my way of progress. So I will not go to that deep into a critical concept immediately. So I will hold it here. I will remember this. I have to discuss about this. Okay, but till now, what are my effort to understand you that if any case wherever it is needed to use the direct formula for those series I have shown, the natural series, the odd number series or the even number series, you can put this formula directly to get the result. Okay, so without wasting much of the time, I will move to the next set of problems that I have started. I will continue the way I am teaching because I have to progress, or I need to progress in a slower manner, in a progressive manner, so that the tougher problem should come later. That is just for an example that I have taken that goes in a critical way. So I need to stop there. So I will progress accordingly from the simpler problem to the tougher at the end of the course. Okay, so now the next problem that will come is sum of the fourth and eighth term of an AP is 24 and the sum of the sixth and 10 terms is 44. Find the first three terms of the AP. Okay, so now it's already said that we are talking about the AP series, the sum of the fourth and the eighth term. So we can assume the first term of that AP be A and common difference is D. That we can assume to establish the thing. Now sum of fourth term and the eighth term of an AP series 24. So the fourth term, that means T4, and eighth sum plus T8 is equal to 24. This is my first equation, and my second equation is that sum of sixth term plus sum of 10th term is equal to 44. This is my two equation as per the question given. So from there we can put the value of T4 and T5 and accordingly this one with respect to A and D. So T4 will be the first term plus n here it will be 4. So 4 minus 1 into D, and for T8 it will be A plus 8 minus 1 into D. This is the formula, and if I go further by simplifying this, what will get A and A, it will give you 2A. Okay, and this if I take D common, this will be 3D and this will be 7D. So ultimately I will get 10D and this will give you 2. So now you can see all the terms are a factor of 2. So I can reduce it by dividing by 2 and will get a simpler equation, that is, now I can name it 1I. Okay, and name it 1Y. Accordingly this can also be said as A plus 6 minus 1 into D, and this one is A plus 10 minus 1 into D, that is equal to 44. by simplifying I will get 2a plus 5d plus 9d, that is equal to 14d, and is equal to 44. Again I can reduce by 2, as it is factor of all are factor of having 2, and we will get 22. So this is my 2i equation, second equation. So if I simplify, or you can solve these two equations, this one and this one, you can know how to solve equations. It is linear equations. So from there, by deducting this 2i minus 1i, you will get d is equal to 2d is equal to 22 minus 12, that is equal to 10. So d I am getting as 5. So once I got the value of d, I can put it any of the equation to get a. So what would be my a? A is equal to, putting d is equal to 5 as at 25, taking together, so b a is coming 13. Okay, so the next equation is that find the first three terms of AP. So with that I can see the first term itself is 13, and the next term, as d is positive 5, so it will be an increment of 5. So minus 13 plus 5, it will give you minus 8. Okay, because there is a negative side, the thing the digit wise it will reduce, but the value wise it will increase. Okay, so minus 13 is lesser than minus 8. Then further, if I add 5, I will get minus 3. So this will be my first three term of the said AP series. Okay, so this will be my answer. So I will end up here. In the next video I will continue from 5 and onwards. I will go slowly, and I will proceed from the simpler to the harder problem. So but anyhow I will remember that one, I will not miss that. I will discuss how to get the sum of those series, 1 square, 2 square, 3 square, or 1 cube, 2 cube, 3 cube. Those are having a general procedure, but you need to understand how I am proceeding. Once you understand for one, you can make it for all. Okay, so I will, but that needs some understanding, so I will not immediately jump into that. So that's why I stopped there. I will progress from the means easier problem to the tougher problem. Okay, so thank you for now.